Introduction. Students, can you tell what we get when we join 2 points?
A line.
Yes, we get a line when we join 2 points. And what do we get when we join 3 points?
A triangle.
Yes, we get a triangle. We also get collinear points. Today we'll study about quadrilaterals. A quadrilateral is formed when we join 4 points. Objectives. At the end of this lesson, you'll be able to define quadrilateral, define and draw different types of quadrilaterals, write the angle sum property of a quadrilateral, write the properties of a parallelogram, solve examples based on the properties of a parallelogram, write the condition for a quadrilateral to be a parallelogram, and prove the midpoint theorem. Introduction to quadrilaterals. Look at the figure ABCD. This is a quadrilateral. A quadrilateral has 4 sides, 4 angles, and 4 vertices. Here AB, BC, CD, and DA are the 4 sides. Angle A, angle B, angle C, and angle D are the 4 angles. And A, B, C, and D are the 4 vertices. Now, what will happen if we join its opposite vertices? If we join the vertices A to C and B to D, we get the diagonals. So, AC and BD are the diagonals. Look at these shapes now. These all are quadrilaterals because they have 4 sides, 4 angles, and 4 vertices. Angle sum property of a quadrilateral. The sum of all the angles of a quadrilateral is 360 degrees. This is called the angle sum property of a quadrilateral. To find the sum, let's divide this quadrilateral into 2 triangles by drawing a diagonal. Let AC be a diagonal and ABC and ADC be the 2 triangles. We know that the sum of all the angles of a triangle is 180 degrees. Therefore, in triangle ABC, angle BAC plus angle ACB plus angle B is equal to 180 degrees. Mark it as 1. Similarly, in triangle ADC, angle CAD plus angle ACD plus angle D is equal to 180 degrees. Mark it as 2. Now, by adding 1 and 2, we get angle BAC plus angle ACB plus angle B plus angle CAD plus angle ACD plus angle D is equal to 180 degrees plus 180 degrees, which is equal to 360 degrees. Also, angle BAC plus angle CAD is equal to angle A, and angle ACB plus angle ACD is equal to angle C. So, angle A plus angle D plus angle B plus angle C is equal to 360 degrees. Or, angle A plus angle B plus angle C plus angle D is equal to 360 degrees. That is, the sum of the angles of a quadrilateral is 360 degrees. Types of quadrilaterals. 1. There are different types of quadrilaterals like trapezium, parallelogram, square, rectangle, rhombus, and kite. Look at these figures. We will go through them one by one. First one is trapezium. A quadrilateral is a trapezium if it has one pair of opposite sides parallel. Here opposite sides AB and CD are parallel, so ABCD is a trapezium. Next is parallelogram. When both pairs of opposite sides of quadrilateral are parallel, then such quadrilateral is called a parallelogram. Here opposite sides PS and QR and SR and PQ are parallel. So PQRS is a parallelogram. Types of quadrilaterals 2. Now come to rectangle. In rectangle, the opposite sides are parallel and equal in length, and all angles are equal to 90 degrees. Here, AB is parallel to CD and AD is parallel to BC. And the angles A, B, C and D are of 90 degrees. So, ABCD is a rectangle. Next is rhombus. A rhombus is a parallelogram whose all the sides are equal. Here lines DE, EF, FG and GD are equal in length. So DEFG is a rhombus. Look at this figure now. This is a square. A square is a rectangle with all the sides equal. ABCD is a square. The last one is kite. The two pairs of adjacent sides of a kite are equal. Here AD is equal to DC and AB is equal to BC. So ABCD is a kite. Properties of a parallelogram. 1. The property of a parallelogram says that a diagonal of a parallelogram divides it into two congruent triangles. Let's prove this theorem. Let ABCD be a parallelogram and AC be a diagonal. We can see that the diagonal AC divides parallelogram ABCD into two triangles, triangle ABC and triangle CDA. We need to prove that triangle ABC and triangle CDA are congruent. We can see that in triangle ABC and triangle CDA, BC is parallel to AD and AC is a transversal. So, angle BCA is equal to angle DAC because these are pair of alternate angles. Also, AB is parallel to DC and AC is a transversal. So, angle BAC is equal to angle DCA because these are pair of alternate angles, and AC is equal to CA because this is common in both the triangles. So, by using ASA rule, triangle ABC is congruent to triangle CDA. Or we can say that diagonal AC divides parallelogram ABCD into two congruent triangles ABC and CDA. Properties of a parallelogram 2. Now we know that a diagonal divides the parallelogram into two congruent. If we measure the opposite sides of a parallelogram ABCD, we will observe that AB is equal to DC and AD is equal to BC, which is another property of a parallelogram. It says that in a parallelogram, opposite sides are equal. This theorem can also be stated as if a quadrilateral is a parallelogram, then each pair of its opposite sides is equal. The converse of this theorem results in another property. This says that if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Let us prove this theorem. Given a quadrilateral ABCD such that AB is equal to CD and AD is equal to BC. To prove ABCD is a parallelogram, draw a diagonal AC. AB is equal to CD and AD is equal to BC. AC is equal to AC common. Therefore, by SSS rule, triangle ABC is congruent to triangle CDA. Also, angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Because congruent parts of a congruent triangle are congruent. Therefore, AB is parallel to CD and AD is parallel to BC. Hence, ABCD is a parallelogram. Properties of a parallelogram 3. Another property of a parallelogram says that in a parallelogram, opposite angles are equal. The converse of this theorem says that if in a quadrilateral each pair of opposite angles is equal, then it's a parallelogram. Now let us find one more property. Draw a parallelogram ABCD and draw both its diagonals intersecting at the point O. If we measure the lengths of OA, OB, OC and OD, we will observe that OA is equal to OC and OB is equal to OD. Or we can say that O is the midpoint of both the diagonals. If we repeat this activity with more parallelograms, we will find that O is the midpoint of both the diagonals. This gives us a new theorem which says the diagonals of a parallelogram bisect each other. Properties of a parallelogram 4. The converse of this theorem results in one more theorem. The converse says, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Let us prove it. It is given that OA is equal to OC and OB is equal to OD. Angle AOB is equal to angle COD because these are vertical angles. Similarly, angle AOD is equal to angle BOC. So, by SAS rule, triangle BDC is congruent to triangle BAT. Therefore, angle BDC is congruent to angle ABD. Congruent parts of the congruent triangle are congruent. Similarly, angle ADB is congruent to angle CBD. From this we get AB is parallel to CD. Similarly, BC is parallel to AD, using converse of alternate interior angle property. Therefore, ABCD is a parallelogram. Diagonals of rhombus. Let us now prove that the diagonals of a rhombus are perpendicular to each other. Consider the rhombus ABCD. We know that AB is equal to BC is equal to CD is equal to DA because all the sides of a rhombus are equal. Now, in triangle AOD and triangle COD, OA is equal to OC because the diagonals of a parallelogram bisect each other. OD is equal to OD is common. AD is equal to CD, sides of a rhombus. Therefore, by using SSS congruence rule, triangle AOD is congruent to triangle COD. This gives angle AOD is equal to angle COD because congruent parts of a congruent triangles are congruent. But angle AOD plus angle COD is 180 degree because these are linear pair angles. So, 2 angle AOD is equal to 180 degree. Or angle AOD is equal to 90 degree. So, the diagonals of a rhombus are perpendicular to each other. Example. Let us now solve one problem. Show that the bisectors of angles of a parallelogram from a rectangle. Let ABCD be a parallelogram. Let P be the point of intersection of the bisectors of angle A and angle B. Q be the point of intersection of the bisectors of angle B and angle C. R be the point of intersection of the bisectors of angle C and angle D, and S be the point of intersection of the bisectors of angle D and angle A respectively. We can see that in triangle ASD, DS bisects angle D and AS bisects angle A. Therefore, angle DAS plus angle ADS is equal to 1 upon 2 angle A plus 1 upon 2 angle D, which is equal to 1 upon 2 into angle A plus angle D, which is equal to 1 upon 2 into 180 degree. Because angle A and angle D are interior angles on the same side of the transversal. Therefore, we get angle DAS plus ADS is equal to 90 degree. Also, angle DAS plus angle ADS plus angle DSA is equal to 180 degree, angle sum property of a triangle, or 90 degree plus angle DSA is equal to 180 degree, or angle DSA is equal to 90 degree. So, angle PSR is equal to 90 degree, being vertically opposite to angle DSA. Similarly, we can show that angle APB is equal to 90 degree, or angle SPQ is equal to 90 degree, and angle PQR is equal to 90 degree, and angle SRQ is equal to 90 degree. We can see here that angle PSR is equal to angle PQR, which equals 90 degree, and angle SPQ is equal to angle SRQ as 90 degree. Therefore, PQRS is a parallelogram in which at least one angle is 90 degree, and so PQRS is a rectangle. Condition for a quadrilateral to be a parallelogram. Another condition for a quadrilateral to be a parallelogram is: a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Given that AB is equal to CD and AB is parallel to CD, we have to prove that ABCD is a parallelogram. Draw a diagonal AC. Since AB is equal to CD, which is given, AC is equal to AC, which is common, and angle BAC is equal to angle ACD because AB is parallel to CD. Therefore, by SAS congruence rule, triangle ABC is congruent to triangle CDA. So, angle CAD is congruent to angle ACB because congruent parts of congruent triangle are congruent. Therefore, CB is parallel to AD. Hence, ABCD is a parallelogram. Examples. If ABCD is a parallelogram in which P and Q are midpoints of opposite sides AB and CD, AQ intersects DP at S and BQ intersects CP at R, show that DPBQ is a parallelogram. Solution. In quadrilateral DPBQ, DQ is parallel to PB since DC is parallel to AB. Mark it as 1. DQ is equal to 1 upon 2 DC, which is given, and PB is equal to 1 upon 2 AB, which is also given. Also, AB is equal to CD because ABCD is a parallelogram. So, DQ is equal to PB. Mark it as 2. Therefore, from 1 and 2, we get DPBQ is a parallelogram. The midpoint theorem. Now we'll study about the midpoint theorem, which says that the line segment joining the midpoints of two sides of a triangle is parallel to the third side. Let us prove this theorem. Draw a triangle ABC. Mark a point E, the midpoint of AB, and F, the midpoint of AC. Draw a line CD parallel to AB, which intersects the extended EF at D. We have to prove that EF is parallel to BC. Comparing triangle AEF and triangle CDF, angle EAF is equal to angle FCD because these are alternate interior angles. AF is equal to FC because F is the midpoint, and angle AFE is equal to angle CFD because these are vertically opposite angles. Therefore, by ASA congruence rule, triangle AEF is congruent to triangle CDF. So, EF is equal to DF and AE is equal to DC by CPCTC. Therefore, BE is equal to AE, which is equal to DC. Therefore, BCDE is a parallelogram. This gives EF parallel to BC. Hence proved. Also here, EF is equal to 1 upon 2 ED, which is equal to 1 upon 2 BC. Converse of midpoint theorem. The converse of the midpoint theorem states that the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Look at this figure. Here, E is the midpoint of AB. Line L is passing through E and is parallel to BC, and CM is parallel to BA. We have to prove that AF is equal to CF. By using the congruence of triangles AEF and CDF, we can prove that AF is equal to FC. Did you know? A square is a rectangle and also a rhombus. A parallelogram is a trapezium. A kite is not a parallelogram. A trapezium is not a parallelogram. A rectangle or a rhombus is not a square. Summary. Let us summarize what we have learned. Sum of the angles of a quadrilateral is 360 degrees. A diagonal of a parallelogram divides it into two congruent triangles. In parallelogram, opposite sides are equal, opposite angles are equal, and diagonals bisect each other. Diagonals of a rectangle bisect each other and are equal, and vice versa. Diagonals of a rhombus bisect each other at right angles and vice versa. Diagonals of a square bisect each other at right angles and are equal, and vice versa. The line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is half of it. A line through the midpoint of a side of a triangle parallel to another side bisects the third side. The quadrilateral formed by joining the midpoints of the sides of a quadrilateral is a parallelogram.